In the problems on this page, we're working with logarithms. So the first one we're going to do is write this log equation in its equivalent exponential form. So we have log base 5 of 30 equals w. So essentially this is saying that the exponent you raise 5 to get a 30 is w. So the way I like to do it is I start with the base, I draw an arrow to there, and then I draw an arrow to there. It goes 5 to the w equals 30. So that is true. The exponent that you raise 5 to get 30 is w. So 5 to the w equals 30 is the equivalent exponential equation. These two are equivalent. All right, and we're not doing any solving, anything like that. We're just simply rewriting it in its exponential form. Very simple. Number 4. Write this exponential or radical equation in its equivalent logarithm form. And notice it is a radical, but the first thing I want to do is get rid of the radical and write it like it's using an exponent. So this is z equals u to the 1/4 power. The fourth root is like using the exponent of 1/4. U to the 1/4 is the cube root of u. The fourth root of u. The fourth root of u is u to the 1/4. And now we basically do what we did, kind of the reverse of what we did in the previous problem. So now I need to write this as a log. So, a log equation. Well, the base of the exponent is u in this term. So the base of the log is going to be u. And I know that the exponent is a 4th, so it goes over there. And that's going to put the z right here. And then I like to go backwards and check it to make sure, because I always know how to go from the log to the exponent. I would say u raised to that power equals that. U to the 4th equals z. U to the 4th equals z. So that's going to be log base u of z equals 1/4. All right, number 5 just says evaluate and simplify the following. Here we have log base 3 of 81. Well, this is the exponent you raise 3 to get an 81. Well, let's see. 3 squared would be a 9. 3 to the 3rd would be 27. 3 to the 4th gives you 81. So that's equal to 4. And if you forget that, if you don't like, that sentence, the exponent you raise 3 to get 81 equals 4, then just set that equal to, say, y and solve for y. And if you rewrite this as an exponential, you get 3 to the y equals 81. So what is that? Well, 81 is 3 to the 4th, so 3 to the y equals 3 to the 4th, so y is equal to 4. So this is equal to 4. Well, in part B, we've got log base 6. Now, we've got a radical here. So the first thing I want to do is get rid of the radical. Log base 6 of 6 to it's the cube root of 6, which is equal to 6 to the 1/3 power. So if you remember the formula, when the base of the log matches the base of this exponent, this is just going to be 1/3. And you can convince yourself of that by rewriting this as an exponential. 6 to the 1/3 equals 6 to the 1/3. So this is equal to 1/3. And this one is there's another shortcut you can remember. Well, it's actually very easy. What is this exponent? Let me do the shortcut first. If you have 2 raised to the log base 2 of any number, then the answer is just going to be any number, whatever is there. If that 2 matches that 2, the base of the exponent term is that 2. The base of the The log, which is in the exponent, is also 2. But you could also simplify this because we know that the log base 2 of 8, what exponent do you raise 2 to get 8? It's 3. That exponent is just equal to 3. So we get 8. All right. Number 6. Use the properties of logarithms to expand this expression as much as possible. So what we have here is, we don't want to use a power rule yet, we can't. We don't want to use a quotient rule, there's no fraction, but we do have two things being multiplied together, 64 times x squared. So we expand that by saying log base 4 of 64, the first one, plus log base 4 of x squared. Now, 2 more minor things that we can do here. I've told you in class many times that when you actually know what the number is when you expand it, simplify that. Okay, so do we know the exponent that you raise 4 to get a 64? Well, 4 squared is 16, and 16 times another 4 would be 64. So we know that 4 cubed is 64. We know that. So this is a 3. The exponent you raise 4 to get 64 is simply 3. Plus, and now we'll use the power rule when you take the log of something that has an exponent, x squared, we can move that 2 down to the front, and we get 2 log base 4 of x. Final answer. 3 plus 2 log base 4 of x.